Welcome to another episode of My Weird Prompts, an AI-generated podcast featuring the random prompts of Daniel Rosehill as answered by a revolving cast of friendly AI characters. Join us for deep dives into AI, technology, and whatever other random thing Daniel finds fascinating today. Subscribe on Spotify or your favorite podcatcher. Now, today's episode.
This episode was generated using artificial intelligence. Please verify facts.
Hey, Herman and Corn. So we've probably all heard that much like our fingerprints and snowflakes, our voices are supposedly all individual and unique. Despite that, we haven't seen a huge uptake in voice biometrics as a authentication method. We've talked about different biometrics previously, and the passkey, and basically what kind of biometrics we're going to actually be using in practice in order to liberate ourselves from the tedium of completing 2FA codes. And of course, the whole concept of using biometrics makes a lot of people very uncomfortable for justifiable reasons and brings with it a lot of privacy considerations. But I'd like to talk about voice identification for a completely different use case today. As you guys know, and we've probably discussed in a whole bunch of podcasts now, I'm a huge fan of voice tech and I'm exploring it a lot at the moment. And some of the tooling that we're seeing actually spring up quite quickly are these utilities for recording. And I'm not talking about recording voice in the context we discussed previously of evidence gathering. Very, very different use case. I'm talking about the much more everyday act of recording with, full knowledge and consent, your voice notes or voice notes including someone else. So my wife and I are beginning to actually use this process. We have, we attempt to institute a weekly apartment meeting where we discuss about our priorities for the week, what we're doing, and we're looking at attempting to get on the property ladder. So a workflow that we're both adopting with, of course, full mutual consent is that I'll record these meetings and then I'll run it through Gemini and say, this is me, I'm Daniel, my wife is Hannah, can you give us a diarized transcription? Now, this works fine, and I guess what I'm asking Gemini to do is say that this is a male voice and diarize this as is Daniel. But my question is this, and it's just really at the tooling level of diarization. Let's say that I wanted to create an app for our apartment, and it's going to be either speaking, just me, just Hannah, or the two of us. Those are the possibilities. So there's two voices. And I guess what I've been thinking about is if these voices are recurring, or maybe let's say there might be 3 or 4 different voices. Let's say we're a whole family doing this, and we can't just say this is a male voice. There are 2 or 3 male voices that might be in the recordings, but they're not going to change. Now, my question is this. We could easily find 30 seconds or 1 minute of a speaker and save that as a voice sample. But I don't know exactly what tooling there is to use that, whether it might be embedding it or something, in order that when I do a transcription, I can diarize it not according to these kind of workaround descriptions saying that this is a young male voice or manually doing a few lines, which is another method. You manually diarize and then if it does speaker 1, 2, 3, 4, it can infer the rest of it. That's also works, but it's also a workaround. So my question is, for doing this kind of diarization based upon actual audio samples of known and recognizable voices, what is the tooling for this at the moment? Herman and Corn, let's talk about diarization in voice workflows and what tools can you use to actually reliably and programmatically identify speakers, especially recurrent ones, in conversations. Over to you, Herman and Corn.
Hey everyone, welcome back to My Weird Prompts. I am Corn, and I'm sitting here in our living room in Jerusalem with my brother,
Herman Poppleberry, ready to dive into the deep end of the audio pool. And we have a really practical one today. Our housemate Daniel sent us a voice note about something he and his wife Hannah are doing. They have been recording their weekly apartment meetings, which sounds incredibly organized, by the way, and they are looking for a better way to handle the transcription and specifically the voice identification.
Right, Daniel mentioned he is currently using Gemini to transcribe the meetings, but he is running into that classic wall where the AI can tell different people are talking, but it does not necessarily know who is who without being told every single time. He is looking for a programmatic way to use actual audio samples of known speakers to identify them automatically.
It is the difference between diarization and speaker identification, and it is a fascinating technical challenge. Most people use those terms interchangeably, but in the world of audio engineering and machine learning, they are distinct processes that often get bundled together.
I think that is a great place to start. Before we get into the specific tools like Pyannote or Picovoice, let us break down that distinction. Because if you are searching for a solution, you need to know what you are actually asking the machine to do.
Exactly. So, speaker diarization is basically the process of partitioning an audio stream into homogeneous segments according to the speaker identity. In simpler terms, it is the machine asking who spoke when. It marks speaker 0, speaker 1, speaker 2. It does not know that speaker 0 is Daniel. It just knows it is the same voice that spoke at the 2-minute mark and the 5-minute mark.
And then speaker identification, or speaker recognition, is the next layer. That is where you take those segments and compare them against a known profile, or a voice print to say, okay, this segment matches the mathematical representation of Daniel Poppleberry.
Right. And what Daniel is looking for is a system where he can provide a few seconds of his voice and a few seconds of Hannah's voice as a reference, and then have the software automatically label the transcript with their names every week without manual intervention.
It sounds like a simple request, but historically, this has been one of the hardest problems in speech processing, especially when you have what they call the cocktail party effect, people talking over each other or background noise in an apartment. But the technology has really leaped forward in the last year or two.
It really has. If we look at how this works under the hood, it is all about embeddings. When a model hears a voice, it converts that audio into a high-dimensional vector, basically a long list of numbers that represents the unique characteristics of that voice, the pitch, the resonance, the cadence.
So it is like a digital fingerprint, but for sound.
Very much so. And the goal of these modern models is to make sure that two different clips of Daniel's voice produce vectors that are very close to each other in that mathematical space, while a clip of Hannah's voice produces a vector that is far away.
So, Herman, if Daniel wants to build something programmatic for his apartment meetings, what are the actual heavy hitters in the tools space right now? I know you have been tracking the open source world pretty closely.
If you want to go the open source route, and you are comfortable with a bit of Python, Pyannote Audio is the absolute gold standard right now. It is an open source toolkit built on top of PyTorch, and it is incredibly modular. As of late 2024 into 2025, their 3.1 version remains a benchmark that most researchers use. .u1.
I have seen Pyannote mentioned in a few of the technical forums. What makes it the leader? Is it just the accuracy, or is it the way it handles the pipeline?
It is both. Pyannote does not just do one thing. It has separate models for voice activity detection, which is just identifying if anyone is talking at all, then speaker change detection, and finally the embedding extraction. The cool thing for Daniel's use case is that you can use Pyannote to extract an embedding from a clean 10-second clip of his voice and save that as a reference file. Then, when he processes a new meeting, the system can compare every speaker it finds against those saved embeddings.
So he could basically create a folder called Known Speakers, put a WAV file of himself and a WAV file of Hannah in there, and the script could just loop through and match them up.
Precisely. There is a bit of a learning curve because you have to handle the clustering logic yourself if you want it to be perfectly programmatic, but the community has built some great wrappers around it. There is a project called WeSpeaker that is also worth looking at. It is a research toolkit that focuses specifically on speaker embedding and speaker recognition. It is trained on massive data sets like Vox Celeb, which contains thousands of different voices, so it is very robust to different recording conditions.
That is interesting. You mentioned recording conditions. Daniel and Hannah are recording in an apartment. I imagine there is some reverb, maybe a refrigerator humming in the background. Does that mess with the embeddings?
It can. This is where the pre-processing comes in. Most modern pipelines will include a de-reverberation step or a noise suppression step before the voice even hits the embedding model. But one of the reasons Pyannote is so popular is that it is quite resilient. It uses what they call an end-to-end neural diarization approach, or EEND. Instead of doing everything in separate steps, the newer models try to learn the whole process at once, which helps them handle things like overlapping speech much better.
Overlapping speech is the big one. In a natural conversation, people do not wait for a perfect 3-second pause to start talking. They jump in, they laugh, they say yeah or right while the other person is still finishing. How does a programmatic tool handle two voices at the exact same time?
That is actually the cutting edge of the field right now. Older systems would just fail or assign that segment to whoever was louder. But newer architectures can actually output multiple speaker labels for the same timestamp. They use something called power set encoding. Instead of just saying, is it speaker A or speaker B, the model can say it is speaker A and speaker B simultaneously.
That is impressive. But let us say Daniel does not want to manage a full Python environment and keep up with PyTorch updates. What about the commercial API side? I know we have talked about assembly AI and DeepGram in the past.
Yeah, if you want something that just works via an API call, the landscape is very competitive. DeepGram, for instance, has their Nova 3 model, which is incredibly fast. They have a feature specifically for diarization where you just pass a flag in your request and it returns the transcript with speaker labels ... .2.
But does DeepGram allow for that specific speaker identification Daniel asked about? Can he tell DeepGram, hey, this is Daniel, and then have it remember him for the next meeting?
That is the catch with most cloud APIs. They are usually doing blind diarization. They are very good at telling you there are two people, but they do not typically store a voice profile for you unless you are using their enterprise-level speaker search features. However, Assembly AI has been moving in that direction. They offer a speaker diarization model that is very accurate, and while it is primarily designed to distinguish between voices in a single file, you can take the output and match it to your own database of voice prints on your end.
So he would still have to do a little bit of the legwork himself. He gets the transcript back with speaker 1 and speaker 2, and then he has to run a small local script to identify which one is him based on the audio segments.
Right, but there is another tool that I think might be exactly what Daniel is looking for, especially if he wants to build a dedicated app for his apartment. It is called Picovoice, specifically their Eagle engine.
Oh, I remember hearing about Picovoice. They do a lot of on-device stuff, right?
Yes, and that is the key. Picovoice Eagle is specifically designed for speaker recognition. It is not just a general transcriber, it is built to recognize specific people. The workflow is very clean. You do an enrollment phase where the person speaks for about 20 or 30 seconds. The engine creates a very small, highly compressed speaker profile. Then, during the actual conversation, it can identify those enrolled speakers in real time with very low latency.
And because it is on device, he would not have to worry about sending his and Anna's private apartment discussions to a cloud server every week.
Exactly, it runs on Windows, Mac, Linux, and even mobile or Raspberry Pi. For a housemate who is tech savvy like Daniel, he could set up a dedicated recording device in the kitchen or living room that automatically recognizes who is talking and logs the meeting notes. It is very programmatic and very reliable because it is looking for those specific enrolled profiles rather than trying to guess the speakers from scratch every time.
That sounds like a winner for his specific use case. But I want to push on the reliability bit for a second. We have talked about how voices are like fingerprints, but voices change. If Daniel has a cold, or if he is tired, or if he is just really excited about a new project and his pitch goes up, do these models hold up?
That is a great question, and it is something researchers call intra-speaker variability. Your voice is not a static thing. It changes based on your health, your mood, and even the time of day. Most high-quality models, like the ones used in Picovoice or the latest Pyannote embeddings, are trained to ignore those temporary fluctuations and focus on the physiological characteristics of your vocal tract, the things that do not change.
Like the physical shape of your throat and mouth?
Exactly. The length of your vocal folds, the shape of your nasal cavity, these things create resonant frequencies called formants that are relatively stable. A good model can see through a stuffy nose because the underlying structure is still the same. However, if you are doing a very high-stakes identification, like for a bank, they usually require a longer enrollment period to capture those variations. For an apartment meeting, a 30-second enrollment is usually plenty.
You know, it is funny we are talking about this, because it reminds me of that episode we did a while back. I think it was episode 196, where we talked about voice cloning. Back then, we were looking at how easy it is to mimic someone's voice. Does that pose a problem for these identification tools? If Daniel's voice is being cloned by an AI, would Picovoice Ego be able to tell the difference between the real Daniel and a high-quality clone?
That is a massive area of research right now, often called anti-spoofing or liveness detection. Most standard speaker identification tools are not inherently designed to detect clones. They are looking for the voice print. If the clone is good enough to perfectly replicate those formants we talked about, it might fool a basic identification system. But the high-end systems are starting to incorporate artifacts that are present in synthetic speech, but absent in human speech. It is a bit of an arms race. But for Daniel's apartment meetings, I do not think he has to worry about a deepfake Hannah trying to sabotage their property ladder discussions.
Hopefully not. Unless their apartment meetings get a lot more intense than I imagine. But going back to the practical side, if Daniel wants to implement this, he mentioned he is currently using Gemini. If he wants to keep using a large language model for the actual summary, or the property ladder analysis, how does he bridge the gap between the raw audio and the final identified transcript?
That is the perfect workflow. Step 1 is the audio processing. He uses a tool like Pyannote or Picovoice to get a diarized transcript. So he has a file that says Daniel said this, Hannah said that. Then he feeds that structured text into Gemini or GPT-4. By giving the model the names up front, he saves a ton of tokens and prevents the AI from hallucinating who said what.
Right, because Gemini is great at summarizing, but it is guessing at the speakers based on context. If someone says, "I will take the trash out," Gemini might guess it is Daniel because of some internal bias, even if it was actually Hannah. By giving it the verified labels from a tool like Picovoice, the summary becomes much more accurate.
Exactly. And if he wants to be really fancy, he can use a tool called Whisper from OpenAI for the actual speech-to-text part. Whisper is arguably the best general-purpose transcription model out there. There is a version called Faster Whisper that is optimized for speed. He can run Faster Whisper for the text, Pyannote for the speaker labels, and then combine them.
Wait, so he would be running two different models at the same time, one for the words and one for the voices.
Yes, that is actually how most professional transcription services work behind the scenes. They have a speech-to-text engine and a diarization engine running in parallel. Then they align the timestamps. If the transcription says the word property started at 10.5 seconds and ended at 11 seconds, and the diarization engine says speaker A was talking from 10 seconds to 12 seconds, the system knows that Daniel said property.
That sounds like it could get complicated if the timestamps do not align perfectly. Is there anything that combines them into one neat package?
There are some integrated pipelines. There is a popular GitHub repository called WhisperX that does exactly this. It takes Whisper for the transcription, uses a process called forced alignment to get word-level timestamps, and then integrates Pyannote for the diarization. It is probably the most powerful open-source tool Daniel could use right now if he wants a one-stop shop for a highly accurate identified transcript.
WhisperX. I will have to check that out. It sounds like exactly the kind of thing Daniel would enjoy tinkering with. But what about the recurring voice aspect? He mentioned that these are people he knows and the voices do not change. Is there any advantage to having months of data? Can the system learn and get better over time?
Absolutely. This is where you move into the territory of speaker adaptation. If Daniel has 50 recordings of himself, he can create a much more robust average embedding. Instead of just one 10-second clip, he can use a representative sample of his voice from different days. This makes the system much more reliable against those variations we talked about earlier, like being tired or having a cold.
It is like building a more detailed three-dimensional map of his voice.
Exactly. And for developers, this is usually handled by a vector database. You store the embeddings for Daniel and Hannah, and then for every new segment of audio, you do a similarity search. If the new segment is 98% similar to the Daniel vector, you label it Daniel. If it is only 70% similar, maybe you flag it for manual review or label it as an unknown guest.
That brings up a good point. What if they have a guest over for one of these meetings? Maybe a financial advisor or a friend. How does a system that is tuned for Daniel and Hannah handle a third unknown voice?
Most of these tools have a threshold setting. You can set it so that if a voice does not match a known profile by at least 85%, it gets labeled as speaker unknown or guest. Pyannote is particularly good at this because it will still diarize the guest. It will say, okay, I do not know who this is, but it is definitely a third person who is not Daniel or Hannah.
That is really useful. It prevents the system from accidentally misattributing the guest's words to one of the residents.
Right. Now, I do want to touch on one thing Daniel mentioned about the current state of things. He is using Gemini, which is a massive model. We are seeing a trend where these large multimodal models are starting to handle audio directly. In the future, we might not need separate diarization tools. You might just be able to upload an audio file to a model like Gemini 1.5 Pro or the latest GPT models and say, here is a sample of Daniel, here is a sample of Hannah, now transcribe the whole thing.
We are already seeing some of that, aren't we? With the ability to upload files directly into the chat interface.
We are, but the reliability for long files is still a bit hit or miss. The specialized tools like Picovoice or Pyannote are still significantly more accurate for speaker identification because that is their entire purpose. The bid models are generalists. They are amazing at understanding the content, but they can still get confused about the fine-grained details of who is talking when the voices are similar.
That makes sense. It is the old specialist versus generalist debate. If you want the absolute best results for a specific task, you use a tool built for that task.
Exactly. And for Daniel's apartment meetings, where accuracy probably matters for things like budget decisions or action items, I would definitely lean toward a specialized pipeline.
So, to summarize the options for him, if he wants open source and is okay with Python, WhisperX, or Pyannote Audio are the way to go. If he wants something on device and programmatic for an app, Picovoice Eagle is a fantastic choice. And if he just wants an easy API, Deepgram or Assembly AI are the commercial leaders, though he might have to do a little extra work to map the speaker labels to names.
That is a perfect summary. And honestly, for a weekly meeting, once he sets up a script using something like WhisperX, he could probably automate the whole thing. He could have a folder on his computer where he drops the audio file, and 10 minutes later, a perfectly formatted, identified transcript appears in his inbox.
That sounds like the dream. No more manual labeling. I can see why he is excited about this. It is one of those small chores that technology is finally ready to take off our plates.
It really is. And it has implications far beyond apartment meetings. Think about journalism or legal proceedings or even just family history. Being able to automatically and accurately attribute speech in large archives of audio is a massive unlock for human knowledge.
You know, it also makes me think about the accessibility angle. For someone who is hard of hearing, having a real-time transcript that clearly identifies who is speaking in a room can be life-changing.
Absolutely. We talked about that a bit in episode 321 when we were looking at AI animation and character voices, but the real-world application for accessibility is even more profound. If you are in a group setting and you can see a screen that says Herman is talking right now, it removes so much of the exhaustion of trying to follow a conversation.
It is amazing how these niche technical questions, like the one Daniel sent us, often lead to these much bigger conversations about how we interact with the world and each other.
That is why I love this show. There is always a deeper layer to the onion.
Speaking of deeper layers, I want to ask about one more technical detail before we wrap up. What about the sampling rate of the audio? Daniel is probably just recording on a phone or a laptop. Does he need high-fidelity equipment to make these identification tools work?
Surprisingly, no. Most of these models are trained on telephone data or standard 16 kHz audio. While a better microphone will always help, especially with noise reduction, you do not need a studio-grade setup. As long as the voice is clear and not overly distorted, the embedding models are very good at extracting those unique features. In fact, some models are specifically designed to be robust to the kind of compression you get on a standard mobile phone recording.
That is good to know. So he does not need to go out and buy a bunch of professional gear just to get his apartment meetings transcribed.
No, his current setup is likely fine. The magic is in the math, not the microphone.
I love that phrase. The magic is in the math. It sounds like a Herman Poppleberry original.
I might have to put that on a t-shirt.
Well, I think we have given Daniel a lot to chew on. From Pyannote to Picovoice, there are some really powerful tools out there that can do exactly what he is looking for. It is just a matter of how much he wants to get his hands dirty with the code versus using a ready-made API.
And I hope he shares the results with us. I would love to see how their property ladder discussions look once they are perfectly diarized.
Maybe we can get him to give us a demo in a future episode.
That would be great.
Before we sign off, I just want to say a quick thank you to everyone who has been listening and supporting the show. We have been doing this for over 300 episodes now. And the community that has grown around my weird prompts is just incredible.
It really is. We love hearing from you. Whether it is a technical question like Daniel's or just a weird thought you had at 3 a.m, send it our way.
And if you are enjoying the show, we would really appreciate it if you could leave us a review on Spotify or whatever podcast app you use. It genuinely helps other curious people find us and join the conversation.
Yeah, it makes a huge difference. We read all of them, even the ones that tell us we talk about vectors too much.
Hey, there is no such thing as talking about vectors too much in this house.
Fair point.
You can find all our past episodes and a contact form at our website, myweirdprompts.com. We are also on Spotify, so make sure to follow us there for new episodes every week.
Thanks for joining us today in Jerusalem. It has been a blast.
Definitely. Thanks to Daniel for the prompt, and thanks to all of you for listening. This has been My Weird Prompts.
Until next time, keep staying curious.
Bye, everyone.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox Turbo.
Thanks for listening to another episode of My Weird Prompts, an AI-generated podcast featuring Daniel Rosehill's AI prompts, as answered by a revolving cast of friendly AI characters including me, Cornelius the Sloth. Subscribe on Spotify or visit myweirdprompts.com.